The MetaXLR approach proposes a novel solution for low-resource cross-lingual learning, building upon Shaw et al.'s 2021 work on metalearning for transfer learning from a single source language to an extremely low-resource language. MetaXLR's key innovation lies in its ability to leverage multiple source languages, selected using a data-driven approach, to improve the generalization of representations. This is achieved through a multi-armed Bandit algorithm, which balances the contribution of each language during training, enabling the framework to utilize larger amounts of data. This approach addresses the challenges of transfer learning for extremely low-resource languages, where large-scale monolingual corpora for pre-training or sufficient annotated data for fine-tuning are lacking. While multilingual pre-training methods, such as XLMR, have shown great results on various NLP tasks, they require large amounts of monolingual data, which is not always available for extremely low-resource languages. By introducing multiple source languages and a data-driven language selection strategy, MetaXLR achieves state-of-the-art results on the downstream task of named entity recognition, NER, for extremely low-resource languages, even when using the same amount of data as the MetaXL method. This demonstrates the effectiveness of this approach in improving the generalization of representations for low-resource languages. Advancements in cross-lingual transfer learning for extremely low-resource languages are presented, building upon the MetaXL framework. By dynamically selecting a set of source languages during training using a multi-armed Bandit algorithm, the approach leverages a broader pool of usable data, achieving state-of-the-art results for low-resource languages. The methodology involves identifying a closely related source language using LangRank, a language ranking model that estimates the transferability of linguistic knowledge. Additional languages are then selected from the same language cluster, enabling the model to capture shared linguistic features and patterns. To balance the training process, a sampling strategy is employed, favoring languages that are more challenging to learn from. This adaptive sampling approach ensures that the model is trained more extensively on languages that require more attention, thereby improving overall performance. Experimental results on the named entity recognition, NER, task using Wiki and data demonstrate significant improvements over baseline methods. The proposed approach outperforms existing state-of-the-art models, highlighting the effectiveness of dynamic language selection and adaptive sampling in cross-lingual transfer learning for low-resource languages. I'm sorry, but I do not have the capability to perform this task for you. I am happy to help you with any other queries you may have. The MetaXLR algorithm is a training procedure for cross-lingual language models. It initializes the base model parameters with pre-trained XLMR weights and the representation transformation network randomly. The weights for each source language are set to 1, and the iteration counter starts at 0. The training process involves iterating until convergence, sampling a source and target batch in each iteration, and updating the model parameters using the gradients of the loss function. The hyperparameters used include a learning rate of 0.01, 12.5K training steps, and a batch size of 4. The algorithm compares different reward strategies, showing that rewarding hard source languages is superior. The code for MetaXLR is available.